And recording is in progress. Okay, so today we're going to hear from Kate Bradwell and Richard Moffitt about harmonizing units and values of quantitative data elements in the N3C enclave, which is the very large nationally pooled EHR data set. And this work has been about a year and a half or two of hard work, and I think it's really made a big difference in the quality of the analyses, and is also, in my opinion, very generally applicable to lots of other contexts. So that's my little advertisement. Richard, are you going to be starting out, or Kate?
I guess I will start out.
Okay, next slide. So
Kate here?
Excuse me. Oh, it's Kate here. That's a very good question.
Oh, there's Kate.
Yeah, yes. Good. Okay. Sure. Okay, and so next week we have the last presentation before the summer break. Vaccine effectiveness domain team, Nadia Safter, and then the monthly Recover Long COVID project team upwards with Emily Boff and Richard. Okay, so next slide. I think this is okay, so we're going to skip that. And Richard, you want to share your screen? And
sure. All right. So while Kate and I are going to be giving the talk today, we want to start by acknowledging the immense amount of effort that both Jacob Woldridge and Harold Lehman also put in on this work, as well as a lot of our co-authors that we'll show at the end. So as hopefully all of us know, in N3C, we take data from multiple different data models. They all get mapped to common OMOP vocabularies, and there's some quality control, and this data is released to us, the community, to be able to work with it. So we have this harmonized data in terms of semantic meanings, whereas any particular piece of data, for example, the unit of measure, is harmonized so that we're all using sort of the same terms, but these units of measure may be different or synonymous. So whereas we all will understand what grams per liter means and grams per mil, sometimes we have this gram per liter or gram per milliliter. Sometimes they're equivalent units, sometimes they're different. Even so, the general point is, even though they're all mapped to the same vocabulary, they can have different meanings or similar meanings. And so just to illustrate this, the problem we have is that different sites will provide their data in different units. So we have a plot over here of real data looking at body weight. And you can see, based on the different units that are provided, understandably, the data come in different value ranges. And you might think this is a relatively straightforward problem. If we know that some of our weights are in kilos or some are in pounds, we can just convert them all to kilograms, right? And we and anybody who's made it past middle school knows how to do this. But the problem is that some sites provide data where the unit is missing or the unit doesn't map to anything. And so the obvious straightforward solution to this is that you go and you contact the site directly and you ask them to, hey, could you please provide units? But this isn't a particularly scalable solution. And some sites have differing amounts of resources that they can use to go play whack-a-mole with missing units. So the solution we're going to talk about today is algorithmic inference. So wouldn't it be great if we could just figure this out? This again is real data on the right. And so on the x-axis, we have the actual values, and these are Cdf plots, so cumulative distribution functions. And these are, again, body weight. But now I've colored it by which unit they come in. And what we want to do here is sort of inspect the values and see that the two sites that are providing us data in kilograms, their distributions are looking similar in green. All the purples are sort of together, all the blues are together. So if we focus in on, there's this one black line that's hard to see hiding in with these purples, maybe we can infer that since the distribution of the data from this site with an unknown unit matches the distribution of the sites from all this that give us their weights in pounds, we can infer that any of these sites here are in fact giving us data in pounds, and we can just proceed that way. So based on these curves, usually it's pretty straightforward to do a color massing. We can probably guess the unit in most cases. But there are some challenges with this approach. The first one is that sometimes the unit of measurement is confounded towards the expectation of the outcome of that measurement. And what I mean by that is that, for example, humans measured in grams or ounces tend to be infants or babies, right? Whereas humans measured in kilos or pounds are more likely to be adults, just in general. So sometimes the test or the unit that is selected is correlated in some way with the outcomes. And this can wreak havoc when you're trying to infer and match distributions. This also comes up a lot where you have like a particular assay and then another type of that assay, which is the quote high sensitivity version of it. So they only use the high sensitivity version when the values are expected to be low. So these can cause problems. The second problem we run across with unit harmonization is that the sites themselves differ from each other. If one site, which we're showing here in orange, if you look at the age distribution, you can see most of their data are coming from children, whereas this site with the green curve, the age distribution is consistent with an enrichment in college age patients, whereas sort of the blue curve is what we expect from the general COVID positive population. So some of these little quirks kind of break some of our assumptions along the way and make this guessing game a little bit of a challenge. But what do we actually want to harmonize? We have to define the entirety of the universe that we're aiming to smush together. If we want to harmonize all of the body weights, but we don't want to harmonize weight of something else, right? We don't want to harmonize weight of urine with total body weight. And so we accomplish that by the construction of concept sets. In this case, all of the measurements in a particular concept set that we construct are intended to be synonymous in terms of units. And so, maybe it's sodium concentration in blood, but sodium concentration in serum. Those are synonymous in terms of what units we expect those measurements to come in. There are some other specific examples we can talk about at the end, but for most of these measurements, the concept sets that you would use for downstream analysis are going to be almost exactly the same as the concept sets that we use to group concepts, measurement concepts together for harmonization. And where you can find all of this, if you go into the data catalog, there is a whole project in the data catalog called Unit Harmonization Materials. If you go there, there's 4 items, and the very first one is a table called Canonical Unit of Measure. And if you click on that, you can see what we're harmonizing, because this table, and this is the actual table here, has 2 columns. One is measured variable, which is kind of like our human readable concept set name, and then a code set ID, which corresponds to a specific concept set version in the enclave. So if you are a little bit lazy and you want to go do an analysis where you have sodium concentration is what you want, one of the first places you could go is look in this table, find our entry for sodium, check out that concept set, and see if that meets your needs. Once we've decided the list of concept sets which we want to harmonize with each other in terms of units, we also need to know what our target unit is. So we'll call this target the canonical unit for that unit of measurement. And so you can see for neutrophils absolute up top, the very first row, we've declared that the canonical unit is 1,000 per microliter. So we want to count thousands of neutrophils per microliter of volume. The second thing that we need is a dictionary for how one might convert all of these units. All of that information is in the bottom table here, again in the data catalog for unit harmonization materials. And here we're looking at unit harmonization conversion formulae. So in this table, I've just filtered it down so we could focus on body weight. But what this list is all of the possible units that we could find in the data, and then the target unit we want to convert to, and then this is the corresponding formula. So if we wanted to, if there was some new unit of measure that we don't have harmonized yet, all we really need is a concept set to build on and a handful of formulae to make these conversions. And in fact, if you clicked here, instructions for unit harmonization, you would find information on how to just make this table and submit a new unit for harmonization. So in terms of objectives for what we wanted to accomplish with unit harmonization, we want to infer measurements in cases where they're missing. So if we don't know the unit, we want to infer it, but we can't exactly harmonize the values if we don't know what units they could be in, right? So that's why we have to guess what the missing unit is. We would like to convert all of these values that are coming in into one canonical value, into one canonical unit, so that analysis doesn't have to worry about what units the data are in. And then finally, our third sort of objective here is that we'd like to null out any values that are ridiculous in one way, because they fall above or below plausible thresholds for physiological viability. This is another example of what the missing data would look like. So here we have CDF plots for both body weight and height. And across the top panel, we have colors indicating the units for known data. And along the bottom are these sites from data that are missing particular units. And you can already start to see like, okay, these guys are definitely going to match up with this red curve, suggesting that whatever data this site is providing is probably in, let's see, it's red, so it's probably like fluid ounce for body weight. So I'm going to go over really quick this unit inference, first step of the procedure, and then I'm going to hand it over to Kate after this. So the reference data come in known units, pounds, ounces, kilos, or grams. So these are sites that provide us good data and provide us what the units are. And we can convert all that data into the canonical unit into kilograms using our formulae. And so now we have this large pool of what we think are correct converted units, which give us sort of like a master distribution of what good data for this particular measurement look like. Then we can take data from a site that is not giving us units. We can hypothetically decide that this unit is either in one of the four potential units that are out there. We convert them into kilograms as if the hypothesis were true. And now we have distributions that we can compare to the ground truth. And hopefully you can see by the shifting left to right here in the cartoon, maybe only one of these distributions is going to line up. So in this toy example, we're kind of implying that the missing unit is pounds, because if you convert pounds to kilograms, the curve for this guy kind of matches the global distribution. So the next step here is we can use a Kolmogorov-Smirnov test for similarity to really try and quantify whether or not these hypothesized distributions actually match the ground truth standard from the whole rest of the data in N3C. What we're going to do from this is get a p-value for these KS tests. And at the end of the day, we're going to potentially accept a very likely match, which has weak evidence against it being the correct answer. So in this particular example, pounds would be accepted as the hypothetical unit for data coming from this one site. So Kate, is your mic open?
Yeah, I can start sharing.
Okay.
Can everyone see this? Oh, sorry.
There you go.
That's beautiful.
So these two figures show the counts of the different units that we're finding, both overall per code set and also per site. So the first figure shows how many different types of unit are found per code set, i.e. measured variable. And you can see that per measured variable, we have data that's, or units that are coming in that are already in the canonical unit are equivalent, so a one-to-one conversion to the canonical unit, or actually non-identical. So that's the count of the unique units that we have. Per site, we have, for each code set, we're seeing how many sites provide just one type of unit. So if you look at all the measurement concepts within a measured variable across the sites, how many of these sites are just including one unique unit? And in general, it is just one type of unit per site that we're finding per code set, which makes our job a lot easier. Because what we end up doing is inferring per measurement concept, per code set, per site, sorry. And so when Richard was showing the other slide, it actually said some other checks are used aside from just the KS test to infer a particular unit or to be confident in inferring a particular unit. And this plot shows what I mean when I say further checks. So here we're looking at the conversion factor fold change between units, or the minimum conversion factor fold change between different units of a measured variable. And on the y-axis, we're looking at basically this measure of the spread of the data. So how much would the data be overlapping with values that are coming in different units? And so these are two other factors that we're taking into account when we decide on whether we can actually confidently infer a unit for a specific measured variable within a site. And you're seeing things such as measured variables such as C-reactive protein. It has a very kind of overlapping set of values. So it's extremely difficult to infer one unique unit for that code set. Also, it's got a pretty high, a pretty small minimum conversion factor fold change between different units as well. So when we're applying the KS test, we actually had a really great suggestion by Steve Johnson to actually use mask known units per measured variable per site, and perform the KS test and see what p-value you get out of the KS test when you perform conversions in the different units, and whether when it's the actual known unit that's used, whether you get a p-value that's much above a threshold that we can assign. Or basically first we plotted the distribution. So when it is the actual unit that the site provided, what kind of p-values would we get from the KS test? And based on this distribution, we chose a specific p-value cutoff, which was e to the minus 5. And we said, this looks like a cutoff that would capture a lot of true positives. So a lot of the units that are in the actual true unit for that site. So this is how we decided on the threshold. We combined that with the other checks in terms of spread and minimum conversion fold change across different units. And that's what we put into a pipeline to be able to infer specific units per site and measurement concept. So whether we had a source unit from the actual site itself or whether we had inferred the unit, we perform this process that you see here to harmonize units. So within a particular code set, which is assigned by the subject matter experts and is expected to contain measurement concepts that are equivalent in terms of the types of units that they would be using and the types of distributions of values that they'd contain. We gather all the measurement concepts within that code set, along with the original or inferred unit, and then the information about what is the target unit, i.e. what will be the final harmonized unit for that code set. And with those three pieces of information, we create a mapping function. So for example, here, the original unit is Fahrenheit, the target unit is Celsius, and the final measurement concept, and the measurement concept is body temperature. And that combination is linked to a specific conversion equation. And that conversion equation is applied based on the mapping function that we're seeing in the data per row of in the measurement table from the patient data. And this conversion equation and the mapping function are actually, we ended up saving them as a Python dictionary. So as you can probably already tell, the whole workflow is pretty complicated. So I've split it up here so I can describe the whole process from start to end. First, we have, in the beginning, we decide, as Richard said, which code sets we want to harmonize, what should be the canonical units that everything's harmonized to for that code set, and what are the maximum and minimum plausible values. And with that measured variable or code set, we have a multi-node template that produces a plot of all the distributions that we're seeing in the data for all the measurement concepts pertaining to that measured variable. And so we can get a sense of what the distributions look like per unit and per measurement concept within that code set. The second output from this multi-node template is a table or a kind of template for a table that allows you to see what measurement concepts are present, what source units are coming in, whether they're valid units, invalid units, or null, no matching concept. And then what the and spaces for inserting a conversion equation from the subject matter experts themselves. And all the conversions for a particular combination of source unit, target unit, and measurement concept are highly curated by the subject matter experts. So we have a group of clinicians and informaticians that are curating these conversion factors. So we're making sure that we have the right conversion factors per measurement concept. And this process of the manual review occurs in the DINH data quality process Google Sheet. From the information that the SMEs provide, we then can populate the canonical units of measure table for that new code set. So what Richard was showing, the table that contains the measured variable, the source unit, the target unit, and maximum acceptable values. We can also populate a set of invalid units per sites. So what we ended up realizing was that a lot of sites have, in at least one case, well, not all sites, but we do notice that across all the sites, I think there was 70, or there are 70 plus sites now, there are at least a few invalid units per measured variable that are coming in. So some sites aren't doing very well at actually providing a valid unit for a measured variable. What we do in this table, invalid units of measure per site, is the SMEs annotate that particular unit, sometimes it's like Kelvin per microliter instead of 1,000 per microliter, is an invalid unit. And so that actually gets saved as an input to the unit harmonization and inference pipeline that I'll describe further in a minute. And so those two pieces of information are captured from the SME annotation, and then also their conversions that they enter for source to target unit for measurement concept are entered, as I said, into a Python dictionary. This Python dictionary is actually accessible from any code workbook or code repository. So you can say from unit conversion. So this is the Python custom Python library that I created in a code repository, import conversions dictionary. And then to use the Python dictionary from that library, you just say conversions dictionary.conversions, and then you can apply or look through whatever conversions you want or the entries in that Python dictionary. But this is an actual input to the pipeline itself, the LDS pipeline and de-identified pipeline as a result. And so those three inputs in total, they get fed into the LDS harmonized part of the LDS pipeline. And first, the unit inference is performed. So the calculation, this happens on a site measurement concept basis. So we're assuming when a unit is missing, as Richard said, we test every single possible unit and see what the KS p-values are, and also look at the spread of the data and the minimum conversion fold change between units, and then derive a final inferred unit based on whether those checks are passed and whether the p-value from the KS test is above the threshold that we empirically determined was did confidently infer the correct unit based on the procedure where we used masked known units previously. And then we get the information of the inferred units in cases where the units were previously null from the sites, or this is where the invalid units table also comes in. We just preserve that information, but we null out those, we treat them as if they were null or no matching concept, and then also infer any record from the measurement table which has an invalid unit present. And once the inferred units are combined with the valid units from the sites themselves, the harmonization of the units process takes place. So from unit to source unit to target unit for measurement concept, we look up the conversion in the conversion dictionary, and then that gets populated into a new column that's harmonized unit concept ID and harmonized value as number. And so That then gets populated into the final measurement table that all the N3C users are able to see and use. And then also a secondary output from the pipeline is the unit harmonization conversion formulae. So this is just a reference. It's not used as an input to the pipeline. It's just built after each data release. So every Tuesday, I put this on a schedule to build so that if we add new conversions into the conversion dictionary, the Python dictionary is then converted to a table, which is called unit harmonization conversion formulae, that anyone can see what conversions are actually taking place in that particular week. And it's incremental, so we just add to the conversions. We only have a few reviewers for conversion formulae to add new conversions currently, so this table doesn't get updated too, or the actual contents of this table that doesn't get updated too frequently. But we're always open to hearing through the instructions for unit harmonization request process, new code sets that members want harmonized. And if they realize that there are maybe a lot of invalid units coming from sites for a particular code set, it'd be great for them to let us know, and we can apply new entries into the invalid units of measure table such that those entries go through the unit inference process and we get a final harmonized value at the end for them. Otherwise, that data is just lost. So to just quickly show the output of the unit inference process, what we're doing is plotting all of the values where the unit actually comes from the site and it's a valid unit, harmonized to the canonical unit per measured variable, which is shown in green here, versus where units aren't present or invalid from sites and are actually inferred and then harmonized to the canonical unit, and their value distributions are plotted. And you can see that it's very similar distributions for if the units come from the site versus if we actually have to infer the units. So that gives us confidence that this process is working well. Overall results from the unit harmonization. So roughly half of the data we actually had to infer or didn't come already in the canonical unit itself, and so had to be harmonized. So this process is saving a lot of data and saving researchers a lot of time by providing the consistent harmonized unit per measured variable. In terms of how we are trying to improve this process, it's incremental improvements. So as I said, we're considering new code sets that we need to harmonize units for. We're considering new equations that need to be entered and new invalid units that are coming from sites for particular measured variables. And all this gets discussed in a monthly meeting. So we are trying to improve this process and harmonize more and more and infer more and more units where they need to be inferred in the measurement table for N3C. And the result of this work was actually published in, when was it, April this year, in JMIA. So we ended up showing the whole unit harmonization and inference process and the pipeline and the results of the pipeline in this publication. So if anyone wants to know further details of how the pipeline is performed or how we ended up doing the validation parts of the unit inference, this would be a good paper to read. So with that, I think they'll take any questions and
Hey, this is Ken. Can you hear me?
yeah.
Yeah. And Richard, thank you. I really sometimes people don't realize, or at least I feel like people don't appreciate how important this is. And I'm wondering, you know, our long-term goal is to get these things out the door to be used by lots of folks. And you know, we're working on this thing where what the question is how could you imagine that some of these, and I'll just call these business rules and rules process, could get placed in a sustainable repository where people could continue to grow the dictionary. So, you know, I'll tell you what I'm thinking, but I'd love to hear your ideas, is that we're very much trying to move all the mapping into a repository that people can edit and change and grow. So our mappings between models don't get old and continue to get version, but it would be wonderful if this could also be what I would refer to as a code map service where you could run unit harmonization. I'm just curious, your thoughts on how do we kind of get this out to the public where it can live and grow and be sustained?
So we have like a sustainable small group that can add changes to it, because of course we wouldn't necessarily want to let world write access to the list of units. But we do have a method by which community members can suggest changes. I think it's been used a handful of times, but not very often. I think like HIV titer was probably the first one that got added in that we didn't use in the cohort paper. I think, Kate, correct me if I'm wrong, but the code base is actually public to do it. You have that on GitHub, especially when we publish this. The tables themselves are actually, as we've been clicking through, relatively straightforward and publicly accessible. It's just about like when somebody says, "Oh, you missed this unit, can you add it?" And that's relatively straightforward as long as, you know, somebody has literally given us the new formula and the unit to convert from and to. And so we've incorporated this once a month cadence in DINH to just like get a couple extra eyes and do a sanity check before we push that into full action. Because, and you know, just reiterate, this is happening all the time. And if you're using the data and you're using numeric measurement data, there's the value as number column, and then there's the harmonized value as number column. So if you're using the harmonized value as number column, all this stuff is happening. And that's definitely where we suggest going.
And Richard, I'm thinking outside of the N3C community. Like I'm thinking, would this repository, if we could wave a magic wand and put this at National Library of Medicine or at NCI, and of course there would still be a process because it's, you know, we don't want a Wikipedia that's wide open to people making messing things up. So it is a controlled change request, but I'm thinking, how do we get this out to the you know, a non-N3C community?
So the library of conversions, I think, would be very easy to export, and I think that's ready for public use. The tricky part about this that doesn't quite export is the unit inference, because the unit inference relies on a reference set. So unless there's a viable reference set, it could be difficult. Now, one way to make that reference set is, you know, we could use N3C as the reference set. There's a certain amount of, you know, if we were to allowed to say, grab 1,000 sodium concentration values and export that curve along with our conversions, and everybody else could normalize to that. That's one way to do it. We'd have to think about governance. But having that reference set of what do values look like in the context of a big splay of all the things that could happen in the hospital. You know, with some of the challenges I noted earlier about different hospital systems are different. You know, if you're a PED site, maybe it would be better if you're compared to other PED sites. There are ways, I think, to get at what you're saying. We just have to be careful.
So Richard, what
Yeah.
about a scenario where you take sort of a big umbrella organization? Obviously, CTSA is one. You say, okay, you have a whole bunch of health systems, and then basically each health system would run a set of, in some sense, benchmarks every few years to essentially generate distribution data. And that would be, I mean, actually in clinical pathology, there is a lot of this sort of quality control that's done across laboratories. So this would be in some sense analogous for data harmonization.
Yeah, I think you know, understanding what you described sounds like it would probably work in sort of like a federated way where you well, but you know, are you describing each CTSA site is like benchmarking to some global frozen distribution or some sort of,
Well, I hadn't
guess,
really
to check against each other? Yeah.
Yeah, well, I mean, basically, if one essentially generates a data abstraction protocol that is, you know, very bland and very, very far from PHI, so that you basically are getting names and distributions, then they don't actually have to interact with each other except when you bring together the names and the distributions of values.
Yeah, I think we could provide that to the community. Just that CDF, just that curve is all you really need.
That's really all you need. And so in some sense, it's easier just to do it once for each health system, where you just basically go through a long list of names and get CDFs. And you know, say every few years there's the grand the grand value unit, the unit
Calibration.
CDF calibration. And that could be, and that way you don't have to do it for this disease and that disease and this subset and that subset. It's very, I mean, this is really, Ken, and Richard and Kate, I mean, the thing that's excited to me about this since you guys began it really is its generalizable nature.
We did it with completely practical motivations.
Yeah.
Just trying to get the distributions to match so we could do a little bit of analysis.
But that's interesting, the idea. I thought that actually is very clever, the idea of having a confidence value based on where you're pretty sure you know the units, and then use that. So by complete coincidence, you come up with 0.05. Who would ever come up with a confidence value, p-value cut off like that?
The surprising part during that process was the number of known units that were clearly wrong. During creating that, I don't know. You could kind of peek and see a little pink on the blue side and a little blue on the pink side.
I mean, that's something also that we can look into, applying a further check to say, even if we've got the units that seem valid from the site, when we look at their distribution, do they fall above the 1e to the -5 p-value cutoff from the KS test? And if they don't, then we could potentially report back to the site that this looks like you've got the unit wrong for this set of values for this measured variable. Also, we can report back to sites where they've given an invalid unit and tell them what we've inferred the valid unit to be, or if they have null or no matching concept units, we can tell them what we've inferred the unit to be, and that kind of makes the kind of check easier for them to say, well, if the inferred unit is this, we want to double check that with what we perhaps should have put as the target unit and sent to N3C. So that, there are various things that this pipeline provides that could be used to improve the data from the sites as well.
Right, and Joanna Lumba, made a nice comment. Is Joanna a panelist? I guess not. Okay, so just today I was talking to the Odyssey Hive Consulting Group, and they confirmed that in general in the Odyssey community, they are not using unit harmonization. They can specify units for cohort criteria that use measurements, but that does nothing for harmonization. This work that you've done is so valuable for all Odyssey users, and local sites could do some harmonization on their local OMOP to support more meaningful federated work.
So yeah, and Kate and Richard and Joel, you know, I love the idea of the very creative, Joel, the kind of local, and then we have a grand unit jamboree, you know, every 5 years where we harmonize harmonizers. But I'm wondering if there's anyway, I think we should come up with whether we set up a test harness for people to use with their data, nothing to do with N3C or way to down, you know, the way to do this. I'd love, you know, we're moving towards the tenant, and the whole idea is a tenant is you can bring in any data, not just COVID data. And part of this is going to be unit harmonization, but we'd like to have a self-service model where people may not want to share their data, but they may ought to use the tenant just for cleaning and QA, right? And so they could have somehow upload their units or their harmonization, you know, do the harmonization and clean up their own local data, and they really never share with the rest of the community. That would be okay too. So I think we should talk about ways to get this out the door. And yeah, you know, I think it'd be great. It really is very important. I agree with Johanna. It's really important what you guys have done. Thank you.
All right, other comments, thoughts? Let's look at the chat. No chat. Okay, well, I think we can give time back, and thanks everybody. Have a great week, and see you next week. And really great work. Thanks.
Yes, thank you guys.